This is 6.1 of Algebra. So we've looked at linear equations on their own before, but now we're going to look at systems of linear equations. So that's when we look at one or more equation at the same time, graphing them at the same time. And any ordered pair that works for both equation is a solution. And so when we're graphing, that's any time that two equations cross, two lines cross, right, and they intersect somewhere, that is a solution. So let's give it a shot. So we're going to graph these two equations here. So I'll draw in my axes. Okay, so remember to graph these, let's look at our first one. You graph your y-intercept first, and then you move with your slope. So my y-intercept, I'm going to put a dot at 4. 1, 2, 3, 4. And then my slope is 2, which is the same thing as 2 over 1. So I'm going to go up 2 over 1, up 2 over 1. And I'm also going to go down to, start back here again, go down 2 into the left 1, down 2 into the left 1, down 2, left 1. And I'll connect that. Okay. And then I'm going to graph my other one. So this one has a y-intercept of 2. Here, let's switch colors just for the heck of it. 2, and it has a slope of 1, which is the same thing as 1 over 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. And you can kind of see just from that picture that they're not going to intersect, right? They're getting wider. So I'm going to go back over here, and I'm going to go down 1, left 1, down 1, left 1, down 1, left 1. And we can see that's where they cross, right? They crossed at this point right there. So our solution then is the point -2, 0. So that would be my answer. That would be my solution. You could also take this point and you could plug it in back into those equations to see if it comes out true. You're going to get something like 0 equals 0, 5 equals 5, -2 equals -2. Then it is a solution. It works. We're not going to take the time. I'm not going to require you to check your answer, although it usually is a pretty good idea. Okay, so we're going to do our got it problem here. So we're looking at two different satellite radio services. So the first option charges $10 per month and a $20 activation fee. And our second one charges $15 per month with a $5 fee. So we're going to write the equations of those first. So if I have it for 1 month, that cost me $10. 2 months, that cost me $20. 3 months, that cost me $30, right? We're multiplying. So it's going to be y equals 10x plus 20. And we're going to do the same sort of thing for our other equation. So y equals 15x plus 5. And we're going to graph that. So I'll draw in my graph. I'm not quite sure how high I'm going to have to go, so I'm going to draw it pretty big. We'll go up by months on our x, so I'm just going to go up by ones. That's months. And then I'm going to go up by fives, so 5, 10, 15, 20, 25. Okay, we'll see if that's high enough. So I'm going to graph my first one. I'm going to put a dot at 20. And then I need to go up 10 and over 1, right? Because you can write it as over 1. So up 10, which is 2 squares, and over 1. Up 10 over 1. Up 10 over 1. Up 10 over 1. And we'll make that our last point. We'll see if we need to go any further if they don't intersect. So I'm going to roughly sketch in a line connecting all these dots. Then I'm going to switch colors and I'm going to graph my other one. So this one has a y-intercept of 5. So put a dot at 5. This time I'm going to go up 15, which means I need to go up 3 and again over 1. So up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Up 1, 2, 3 over 1. And look, we've already crossed, so I'm going to connect those guys. And our intersection's right here at the point 3, 50. So what this means, because this is a story problem, right? This is a real life problem, so it actually gives us some information besides just where they cross. So our x is 3, so at 3 months, this means that both services cost $50. So let's say you went into this knowing I'm going to have this satellite radio service for 3 months. Then it doesn't matter which one you pick because it's going to be the same for either one. But if you were going to have it for less than 3 months, then it makes sense to go with the blue guy because that's cheaper. But if you're going to have it for more than 3 months, then it makes sense to go with the purple guy because it's going to be cheaper for more months. So our solution is $350. So in the 3rd month, the cost of the service is the same. Okay, so the ones we've done so far, they have one point where they cross, right? So that's this one right here where there's one solution. And whenever we have a solution, we call that consistent. But if we have exactly one solution, that's called independent. So this one here is independent. We can also have it where we have exactly the same lines graphed on top of each other. And so you see the picture here. That means that every single point on those lines are a solution. So there are infinitely many solutions because that line goes on forever, right? So there's infinitely many points, so there's infinitely many solutions. And that is called dependent. And then our last one is parallel lines where there's no solution because parallel lines never cross. And when we have parallel lines and no solution, we call that inconsistent. Okay, so if we're trying to see if they have a solution or how many solutions, that sort of thing, we can graph it if you'd like, but we've already worked with some of this, and we can just look at the equation and know. So, like, if we look at this equation, what is the slope of both of those? This has a slope of -1, this has a slope of -1. If they have the same slope, those are parallel lines, right? So for A, those are parallel lines. And we know that parallel lines have no solution. No solutions. And it is inconsistent. What about this one? Well, we can't even start graphing it yet until we get that second equation solved, right? We need to get the y alone. So we've got 3y equals 9x minus 9. So I'm going to divide everything by 3. And I get that y is equal to 3x minus 3. Well, if you look at our first equation and you look at this new one we just solved, those are exactly the same lines. If they are exactly the same lines, then they overlap, right? And they have every single point in common. So there are infinitely many solutions. Because they are the same line. Put that in parentheses, same line. And this was called dependent. And there you go, there's your homework.